Welcome back, everybody. In this video tutorial, I'm going to talk about horizontal asymptotes. Now, just a quick reminder, in a previous video about vertical asymptotes, I defined what an asymptote is, which is an imaginary line on the graph in which the function approaches it, but never actually touches it. Now, there are a few basic guidelines you can follow to determine quickly whether or not a rational function either has or has not a horizontal asymptote. You can basically apply this to any question when you encounter problems in which you are asked to find the horizontal asymptote. Now, like I said before, the problems are going to come as rational functions. If the degree of the numerator is greater than the degree of the denominator, then we do not have a horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then you're going to look at the coefficients of the leading degrees and then divide the coefficients of the highest terms. If the degree of the numerator is less than the degree of the denominator, then you do have a horizontal asymptote which occurs at y equals 0, which is basically on the x-axis. I'm going to go ahead and leave this here actually, just so that if you need to look at it for reference. Now, for the first problem, if the degree of the numerator is greater than the degree of the denominator, we do not have a horizontal asymptote. Just like in this problem. Notice how the highest degree, x squared, is bigger than the higher degree in the denominator, x. Notice how we have a vertical asymptote at x equals -1. Then we have what we call a slant asymptote right here at y equals x minus 2. Slant asymptotes I'll discuss later in a separate video. But I just want you to take a look at this just so that you can see how if we ever run into a problem in which the top degree is bigger than the lower degree, then we do not have a horizontal asymptote. Let's look at a problem now in which the degree of the numerator is equal to the degree of the denominator. For instance, we have g of x is equal to 2x minus 2 over x plus 1. Notice how the highest degree here is x, and the highest degree here is x as well. So what's saying here, what number 2 is saying here is that we must divide the coefficients of the highest terms. So basically 2x over x, which is going to give us 2. So there's a horizontal asymptote at y equals 2. And we can see that here. We have the function g of x is equal to 2x minus 2 over x plus 1. Notice how we have a horizontal asymptote at y equals 2. And we also have a vertical asymptote at x equals -1. Because if you go ahead and set the denominator equal to 0, you're going to have x plus 1 equals 0. We're going to end up with x equals -1. But for this question, we were asked to find the horizontal asymptotes, which occur at y equals 2. Let's look at another example in which the degree of the numerator is less than the degree of the denominator, which means that y equals 0, which ultimately means that there is a horizontal asymptote on the x-axis. Here we have the function g of x is equal to 1 over x squared minus x minus 2. Clearly, the highest degree of the numerator is less than the degree of the denominator. Notice how we have vertical asymptotes at x equals -1 and at x equals 2. We also have a horizontal asymptote, which is what we are asked to find right here on y equals 0. And that's it for today. Thank you so much for watching. Please don't hesitate to leave a comment in the comment section below if you have any questions or concerns. Please don't forget to subscribe to my channel. Go ahead and like this video. This will help the channel grow more and more. And we'll see you in the next video.